A underground nuclear test is somewhat like an earthquake. If it's a megaton nuclear test, the seismologist can tell you it was a nuclear test. But if it's a kiloton nuclear test, they cannot. And then you require radionuclide escape to be certain that it was an underground nuclear test. Not all underground nuclear tests leak. Trace radionuclide detection has been a Hanford and then P&L signature capability since the 1940s and 1965 when P&L was founded. And the result of that interest, that curiosity-driven science, was the ability to measure trace amounts of radioactivity in the atmosphere. That continued until in the 90s. You couldn't wait a month for radionuclides to go around the globe to be collected and measured. People wanted an answer within a couple of days. That's what drove us to begin automated systems for radionuclide measurement in the atmosphere.
These are exciting times in research and development for nuclear explosion monitoring. We work on chemical explosive experiments to understand the signatures of explosions. We study radioxenon in the environment that's produced by industrial processes that may interfere with our detection and characterization capability. And we also study how these materials move through the environment, both subsurface and in the atmosphere. The experiments we do in the field are used not only to gather data to help us understand signatures, but we also use them to test out new sensors, radionuclide sensors, seismic sensors, and other technologies to help mature those, to get them into the field faster.
I started in understanding volcanic eruptions. I'm excited to work on nuclear explosion monitoring at PNNL because we have a history in understanding radioactive material monitoring, and one of the big unknowns in that space is the initiation of that process, which is something that I can help constrain with my geophysical tools. And so when you move from big explosions to smaller explosions, you start bringing all of these processes closer together and you have to study them together. For example, we might use geophysics to observe the creation of a fracture, and we might use gas sampling to understand the transport of gas through this particular fracture. So far, that has not been done.
If I had to summarize 30 years of nonproliferation work, you know you're working on something that's the right thing to work on, that it's needed. You know that you're doing something good, and it's not possible that hardly anyone else can do this.
I would like us to have a safe place for our communities and our families.
The work that I get to do with my partners here at PNNL across the US and across the globe, it matters. We're really improving our nation's ability and the world's ability to detect nuclear explosions, and that keeps us all safer.